All right. So, when we would go to graph polynomials, all right, when we were graphing polynomials, some of the work was already done for us, right? The graphing that we've been doing so far, for example, from the warm-up, which I put right here, all the graphing we've done so far, these polynomials have been factored, all right? When you're out in the wild, okay, you may not run across a factored polynomial, but you might be asked to graph it, all right? And so we need to be able to then get it into a factored form so that we can figure out the information we need. We need to know what the zeros are. We need to know the middle behavior, right? And we need to know the end behavior. It's really just for the zeros, though, I think. Yeah, just for the zeros mostly is what we need it for. Okay? So, let's see then. What kind of stuff? All right. Now, when it comes to factoring polynomials, you will not be able to factor every polynomial you come across. It's just not going to be possible, right? And you already have maybe realized that from the times that you spent with like factoring quadratics and things, okay? Just not everything factors, okay? What we're going to do today is just kind of review some of the basic tools that you have in your tool set that you should try and apply anytime you run across a particular problem, okay? So, the first tool that I'd recommend you always go to, okay? So I'm kind of do it like in a hierarchy, I guess. All right, the first tool I always recommend that you go to is greatest common factor. Okay, greatest common factor. Okay, the biggest thing that divides all of your terms. Okay? Greatest for biggest, right? Common meaning shared, right? If you have something in common with someone, you share that with them, and then factor, dividing it out. Okay? So literally, again, it tells you what it does. It's the biggest thing shared by all the terms that you can divide out. Biggest thing shared by all the terms that you can divide out, right? Because factor is something that divides out. Okay, so let's just take a look at an example here. Okay, let's say I've got 6x cubed plus 15x squared plus 6x. Okay, so right, what's the biggest? Let's just talk about the coefficient. What's the biggest coefficient I could divide out here? A 3, right? Okay, all of these are divisible by 3. Okay, so let's divide out a 3. So if I divide a 3 out of this, I'm left with 2x to the third. Divide a 3 out of this, I'm left with 5x to the second. And divide a 3 out of this, I'm left with 2x. Okay, is there more we could take out here? Okay, they all at least have a single x in common, right? So we'll also take an x out. I still have the 3, so I'll bring that x up next to the 3. And so now I will have 2x to the what? Second power plus 5x to the just x, or x to the 1 if you like. And then if I take the x out of here, what's going to be left? Just a 2. Okay. Is there anything else in common to all three of these terms here? No. Okay? No. And so we have now factored out the GCF. Okay? We factored out the GCF. Okay? Question? Sorry? The 5 here? So 6, 15, and 6. Okay, if you look at those, you can see that they all are divisible by 3. So pull the 3 out, so 15 divided by 3. Okay. Just divide. Now, the directions here, though, they say to factor. All right? Can we factor this anymore? There's no more GCF here, but what's another option we could potentially, what's another factoring that we could do here potentially? Okay. What's the degree of this leftover piece right here? What's the degree of this in the parentheses? In the parentheses. What's the degree here in the parentheses? What is it? 2. Okay, it's quadratic. Do we know how to factor quadratics? Maybe. Right? I mean, we do. Okay, we know how to do it, or we've been shown how to do it, right? So let's also see if we can factor this. Okay, so there is factoring using. That's the greatest common factor right there. There's our GCF, right? But let's take a look at this and see if we can factor this quadratic. Okay, so I'm going to leave the 3x. Okay, actually I'll do it over here. I'm going to bring this up here now. Okay, so now I've got the 3x, okay, and then I still have the 2x squared plus 5x plus 2. Okay? Now, to factor this quadratic, we're going to take our a and multiply it with what? This 2 here is going to multiply back with the, nope, not 3. We want to leave that factored out to factor this quadratic. So imagine that the 3 is like not even there. We're going to multiply the 2 back with the 2 here, the 2. A times c, right? A times c, 2 times 2. And that's 4. Okay? And we're going to look for two numbers that multiply to make 4, but that add to make what? 5. Okay, so yes, 4 and 1. Okay? So I'm going to keep bringing that 3x along for the ride here. We'll take the 2x squared. I'm going to break that 5x up using the 4 and the 1. Okay, so again, I broke the 5x up using the 4 and the 1 there. Okay? And that's those numbers we got from doing our little a times c thing, where we had two numbers that multiplied to the 4 and added to the 5. Okay? And now what do I do? We're going to group, right? Group the first 2, group the second 2. Okay? From this first group, what can we take out of there? A 2x, right? So I still have the 3x. I'm going to take a 2x out of this group. Okay? If I take a 2x out of this, what's going to be left behind? An x. If I take a 2x out of this, what will be left behind? A 2. Okay? What can I take out of this group? Just a 1, right? I mean, there's the only thing that can divide both of those is a 1. So I'll do 1, and then again, have an x plus 2 there. Okay? And then they both have that x plus 2. Oops, I forgot my x here. Sorry, 3x there. So we'll have 3x then. I'll pull out the x plus 2. If I take out the x plus 2's, what's going to be left over here? 2x plus 1. And there it is, and it's fully factored form. Okay, there it is, fully factored. Okay? That's about as yucky as it gets, right there. Okay, that's about as yucky as it gets, right there. Okay? That's about as yucky as it gets. All right. Questions on any of that? Yes. Sorry? Is this an equation that we started with? No. So just for now, I see what you're getting at. We will get to those. For right now, all we're asked to do is just factor. So our final answer is just the factored form here. But yes, Julian, yes, a typical then thing we'll also do is we'll have this like equal to 0, and then we would set each factor equal to 0. Yeah. Mm-hmm. We're not there yet. I just want to make sure you can do the factoring stuff first, because that's even more steps, and I don't want to make it too much. You know, some of you might be thinking, Mr. Witt, this is already too much. Fair enough. All right, let's try another one. Again, same directions. Let's just factor here. Okay, 2x to the third minus 20x. Okay. So these directions, right? When you see just factor. That's like that word simplify. It can mean a lot of different things in a lot of different contexts. And so we need to be, comfortable with kind of interpreting what we have to do here. All right? So again, when we said factor up here, the first thing I'd always recommend you look for is if there's a GCF, a greatest common factor. Okay, always check that first. Then with whatever you have left over, so here's what we had left over, right? We took the 3x out, and here's what was left over. All right? See if you can factor that further, right? It's a quadratic in this case, so we factor the quadratic, and then we were able to fully factor it there. Okay, we can't break those down anymore. All right, let's take a look at this next one, though. All right, is there a GCF that we could pull out here? Yes. Okay, so what can we pull out? 2, and an x, right? If you want to do it all at once, feel free. If you want to take care of the numbers first, like we did up here, and then pull out your x's, you can do that too. You can do it step by step, or you can do it all at once. Let's do this all at once, because this is pretty straightforward here. We'll take a 2x out. If I take a 2x out of this, what will be left behind? 1x squared, or just x squared? And if I take a 2x out of this, what will be left behind? Just a minus 10, okay? If you're ever unsure if you factored out correctly or not, just imagine redistributing here. If I did the 2x times the x squared, I would get 2x cubed, right? If I did 2x times minus 10, I would get minus 20x. So you can see, okay, we did it right. It's the same thing. Okay, now, I got my GCF, but, I got another quadratic here. All right, so let's see. My quadratic is really x squared plus 0x minus 10, right? If I put in that missing kind of middle term there. Okay, so let's see if this factors. I'll do my a, which is 1, times negative 10, and I get negative 10. So again, there's my a is 1, my c is negative 10. So 1 times negative 10, I get negative 10. Okay, are there two numbers that multiply to make negative 10, but that add to make 0? Are there two numbers that multiply to make negative 10, but that add to make 0? Well, they would need to add to make 0. So negative 10 times 0 would multiply to make 0, but they don't add to make 0, right? So we need so the answer is no, right? If we try negative 2 and positive 5, that doesn't add to make 0. If you try 2 and negative 5, that does not add to make 0. If you try negative 1 and 10, that does not add to make 0. And if you try 1 and negative 10, that does not add to make 0. And so the answer, does this factor? No. Your final answer was that one right there. Okay? Does not factor any further. That's it. It's that easy. It's that easy. Okay? All right, let's try another one. 3x to the third plus 7x squared plus 4x. And again, this is another factor. Okay, sorry. 3x to the third plus 7x squared plus 4x. Okay. All right, Ava. Oh, she's out at a meeting. All right, well, let's go to Cheyenne. Cheyenne, is there a GCF here we can factor out? Something in common to all three of those terms there? Yes, an x. So we'll take an x out. And what will be left behind here, Cheyenne? If I take an x out of this, what will be left? Yes, very good. And then? Yep, and then? Very good. Okay. All right. Thank you, Cheyenne. All right. Brandon, is there anything else we can take out? Brandon S. Sorry, Brandon S. Is there anything else we can take out there, Brandon, that's in common to all three terms? No. Okay? And that's important to recognize here, folks, right? While Cheyenne, she pulled out, she saw something that we could pull out, it's also important to recognize there's no more that we can pull out. Okay? That's important too. Okay? No more we can factor out. Okay? So then, we are left with a quadratic, though. So we got to check to see if this quadratic factors. So let's see here. X, 3x squared, plus 7x plus 4. Let's see if it factors. So Wyatt, in this quadratic, what is our a term? Yep, so we'll just use the 3 there for the a. Okay, so there's our a times our c. Wyatt, what is our c? 4. So 3 times 4, Wyatt, is 12. Okay, so we are looking for two numbers that multiply to make 12, but that add to make 7. Wyatt can give me two numbers that multiply to make 12. Yes, very good. Hey, that's where we got those from, right? And do they add to make 7? Yeah. Yes. Okay, so this thing will factor. All right, I'm going to break up that middle term to be plus 3x plus 4x plus 4, like that. Okay? Group the first two. Group the second two. All right, thank you, Wyatt. We'll go on to someone else here. Nick. Nick, from this first group, what can we factor out? 3x. A 3x. Very good. So I pull out a 3x, and then what will be left over if I take 3x out of this one? X plus 1. Yeah, just an x, and that one will then be a 1, right? Because I took I took everything out, so it's going to be leaving a 1 behind, right? We're dividing here when we factor it out, so that means 3x divided by 3x gives us a 1. Okay, good. Thank you, Nick. Let's go to CJ. CJ, how about from this section right here? What can we factor out here? Does this have an x? A 4. There we go. Just a 4. Yep. Okay, and what will be left behind when I pull the 4 out of this? X. And if I divide this one by 4, what's left? 1. Okay, great. And that's good news because we get those x minus 1s there in common, so we'll factor those out. So we still have the x in front. Don't forget to keep writing this x in front. And then we'll have the x plus 1. And then, CJ, what's going to be left over? If I take out these x plus 1s, what will be left over? Very good. Awesome. Okay, and there it is fully factored. Okay, there it is fully factored. Alrighty. Questions on any of that? All right. Let's see here. Do I have one for you all to try? Looks like I do not. All right. Let's try another one here then. I'm going to throw one more strategy at you here, and I think, well, I think you've seen this one before, so I might, well, we'll see. All right, I'm going to write this one out. Again, factor. X cubed minus x squared plus x minus 1. Okay. Is there a GCF with this particular polynomial? Can we factor out a GCF here? No. Yeah, no. These 3 terms have an x, but this 4th one does not. And then there's no number we can pull out. Okay, is it quadratic? Is it quadratic? Yeah, it's got a square in it, but it's not quadratic because what is the degree? The degree is not 2. Oh, sorry, cubed. Sorry, I thought you said 2. The degree is 3 or cubed. It's a cubic. Okay, cubic. So this will not factor like a quadratic. Okay, we cannot do a times c here. Okay, we cannot do a times c here because it's a cubic, not a quadratic. Okay, so there's no GCF. There's no, it's not quadratic, so you can't factor like a quadratic. Can't do a times c. But there is something we can do here. There's 4 terms, and so we can group it. Exactly right. Is that what you're going to say too, Nick? Yeah, good. Okay, group it. Okay, so long story short, grouping is a technique that you can use for more than just factoring a quadratic, right? Grouping is something you can use for more than just quadratics. Yes, it works here, but remember we have to like kind of break it up first to make it a grouping problem. Sometimes the grouping problem just presents itself, okay? Now, just because there's 4 terms doesn't mean grouping's going to work. Let's see if grouping's going to work here, okay? From this first group, all right, let's go to AJ. AJ, from this first group here, what can we take out? AJ, from this first group here, what can we take out?
X squared.
An x squared. Very good. Okay, if I take an x squared out of this, AJ, what's left? Just an x. And then if I take the x squared out of here, what will be left?
Nothing.
Not nothing. What's x squared divided by x squared? It's something divides by itself. You're left with a 1. There you go, minus 1. Okay, good. Thank you. All right. Thank you, AJ. All right, let's go to Brandon O. Is there anything we can take out of this second group here? Yeah, there's just a 1 we can pull out. And so we'll still have the x minus 1. Okay. We grouped and we factored from each group. Can we do factoring by grouping? Can we continue here? Yes. What about our results here? What about these results indicate we can continue to factor? What were we looking for here? Okay, yeah, we have an x minus 1 left over, okay? Since they're both the same, we can then factor those, we can further pull those out. So we'll have an x minus 1, and then what will be left behind once I factor out the x minus 1? x squared plus 1. Exactly right. Okay? This is quadratic. We could check to see if we can factor this as well. So let me just show you that here real quick. X squared plus 0x plus 1. 1 times 1. So our a is 1, our c is 1. A times c is going to be 1 times 1 there, which is 1. Okay? We're going to look for two numbers that multiply to make a positive 1, but that add to make 0. Okay? Are there two numbers that multiply to positive 1 but add to make 0? No. No. This does not factor. Okay? So that's as factored as it gets right there. Okay? And that's our final answer. All right? Factoring by grouping. Ta-da. Okay. All right, let's try one more here, and then I'll finally give you guys one or two to try. Okay? Questions on any of that so far? Oh, sorry. Thank you for saying something, Mike. All right, factor x to the third plus 3x squared. Whoops. Sorry, I didn't mean to write that way. X to the third plus 3x squared plus 3x plus 2. Okay, that'll be our next one here. All right, let's go to Jason. Jason, is there a GCF here for us to factor out?
No.
No. Very good. All right. So is it quadratic, Jason?
No.
No, it's a cubic, right? Got the highest degree there is 3. All right. So we can't factor like GCF. We can't factor like it's a quadratic because it isn't quadratic. So then what's our one other strategy we have? Grouping. Okay, so again, this was grouping. Okay, right there, and we're going to try grouping right here. Okay, so if you want, you can say, okay, we tried GCF, it didn't work. And it's not a quadratic, so we'll cross that one out too. It's got to be done by grouping. All right, let's group it. There's an even number of terms here, so we'll group the first two, group the second two. Okay, let's go. Thank you, Jason. We'll go to someone else here. Let's go to Braylon. Braylon, from the first group here, Braylon, what can we take out? What's in common to both terms? X squared is correct. When we take an x squared out of x to the third, what's going to be left behind, Braylon? Just what? Oh, well, yeah, the 3 here for that one, because it took the x squared out, so just the 3. What about if I take x cubed, I divide out an x squared, what will be left? X. Okay, very good. All right, Braylon, from the second group, what can we take out? Yeah, nothing, so we'll just put a 1 in front. Okay. Braylon, was our factor by grouping successful? Can we continue to factor? No. What's the problem that we ran into here? Our leftover here is x plus 3. What's our leftover here? Are they the same? No. So we can't factor that out. Okay, AJ? What? So if they're not the same, then what does that mean about this? Not factorable. Doesn't factor. Okay? Okay, this does not factor. So the final answer is x cubed plus 3x squared plus 3x plus 2. It just doesn't factor. Okay? Does not factor. That's our final answer. Okay. Now you ready to try some on your own? No? I'll take your no as a yes. All right. Let's see how we do here. Yeah. Yes, you may. Yes, you may. Use the restroom. All right. Gotta find where I put that paper. It's got all the stuff on it that I want to do. Maybe I didn't pull that part out. All right, here's some for y'all to try. for y'all to try. Y'all. That's okay. It's made of wood and metal. It will survive. Okay. Try these two. And again, the directions are just to factor. Okay, there's your first one. Here's the second one. Okay, and I'll give you a third one here too. Got to think about this one. That is a 204. You are not tripping. Okay. Don't worry. The 204, I think it'll be maybe not obvious, but I think it'll kind of present itself where it's supposed to. Yeah. Okay. Go ahead. Try 1, 2, and 3 there. Okay. Factor, factor, factor. Okay. So remember, we tried 3 different strategies for factoring here. 1, GCS. Okay, GCF. Also, if it's quadratic, try factoring like it's a quadratic using A times C, right? 3, okay, you can also factor using grouping too, okay? So GCF, that's one of your tools. Always check that first, then quadratic, then grouping, okay? The other 2, you just kind of do if you see them or not. That's really it, okay? All right, and I'm going to do them too here real quick. Okay, and I'll give you a hint. All of these can be factored. Okay, I didn't give you anything that couldn't be factored. Oops. So I think I made an error here. Let's pull out a 2. Could you try factoring out a GCF number 2 first? Try that. GCF first. Okay, that might help lower your numbers a little bit, make it a little bit easier. Okay, and then also there's 4 terms, so that's a good candidate for what strategy that we normally use if there's 4 terms. Oops. Darn it. Okay.
Save like here, $1,800.
Okay, so be careful. There would still be a minus 1 at the end there. Because when you divide the 2 out of that, it'll be minus 1. So yeah, 2x squared, well, so x up here, so you then 2x squared plus x, and then, yeah, plus minus 1. Okay, so then you'll have to factor this too. Enough stuff? Okay, how are you doing here? Yeah, so, okay, you've got x minus 6 and x minus 6, so it doesn't pull those out, okay? And then what's left over, put in the relative. You're on the right chapter, right? Doing all right so far? Okay, that's a good idea, take it out to 2. Okay. That's 1, looks good. So you stuck at this point? Okay, so I see 4 terms, right? 1, 2, 3, 4. So first of all, there's no more GCF, right? There's also, it's not quadratic because you have a cubic there. But I see 4 terms, right? So I see 4 terms. So root these 2, see if you can pull out a GCF from those roots, okay? Okay, CJ? Yes. Yep, if you want to, you can pull out the GCF first. Pull out the 2 first can help because it kind of like lowers all the numbers, makes the math a little bit easier to do. Your choice though. You can do that just off the bat if you want to. Yep. So if you pull a 2 out, then you will have a 1x cubed there. Yes, that's right. Hello, Miss Mary. Okay. Okay. Good. Did you pull that out then? Yes. Okay. Where's the rest of this? You see what I'm saying? Like there's x minus 6, you can still pull out that. Okay. I got you. So yeah. One looks good. Number 2 will be a 2x squared. Sorry, number 3. Sorry, it'll be a 2x squared there. Oh, we'll pull the 2 out right, and then you can factor that quadratic. Okay, so try and factor that quadratic. That quadratic back. You can pull that 2 out if you want to. You can leave it in as well. But it's best if you're like, don't leave factor it. No, you can leave it in if you want to stop there. Yeah, but yeah, I would be okay. 1 out of 2. Like 1 out of 2 is not most important. If there was like a variable in there, you definitely want to plot a variable. Okay, but I think that's okay. Yeah, but you should. Yeah. Well, I don't know. I guess for Julian, yeah. For on the test, I would want you to plot everything. I'm going to multiply the 1 on the top. I'm going to add the 1 on the bottom. Wait a minute. I think it's in a different position than I'm used to. Sorry. When you do the A times C, that number that you get, that's what you multiply to B. You want to add to the middle. Okay? So multiply to the A times C. So in other words, in your case, you're going to multiply this one, you're going to add that. Okay? But you need to be consistent on where you put those numbers too. And then, yeah, that'll be what it is. What can you back up from the first group? 2 out of that group.
He probably had one.
Right? 4 and 2 will both divide by 2. No, you're right. It was minus. It's minus. I have this in a different order. I know. It does throw people with these. Got it? Okay. Well, okay. There are our answers. 1, 2, 3. Okay. 1, 2, 3.
Oh, it's Casablanca.
Okay.
I didn't see that movie.
1, just GCF alone. That's all you got to do. Factor out a greatest common factor. Okay, x squared goes out, x plus 7 is left over. There's nothing you can do to factor out x plus 7 anymore. You're done. Number 2, okay, you've got to, well, I see here they're all even, so I divide out of 2, okay? Some of you maybe looked at it at first and thought, oh, there's 4 terms, I'm going to try grouping. And you could do that. That's fine. In fact, that's what I did at first, but then I'm like, ooh, let's pull the 2 out first because I got some big numbers there I want to deal with, okay? So I factored out a 2 first. And that left me with x cubed minus 6x squared minus 17x plus 102, okay? And then I grouped. From the first group, I took out an x squared. From the second group, I took out a minus 17. And it left me with an x minus 6 that was in common to both. And so there it is, fully factored. Okay? And then number 3, again, I see a GCF here. They're all divisible by 2. So I took the 2 out. Some of you went right in to start factor like a quadratic. That's fine. That's fine. Okay? Either way, eventually you'll factor down to something like this. Okay? If you never factored out your GCF here at first, if you didn't factor GCF out at first, yours might look slightly different. You might have like a 2x plus 2 here times a 2x minus 1. Or you might have an x plus 1 times a 4x minus 2. Okay? But that's the idea. All right. Questions on any of that? All right, your homework then is going to be on page 228, which is... I don't have a section. Goodness. All right, hang on, folks. Sorry, let me get to this section number. Forgot to write that part down. All right, yeah, 6-4. One, 4, 6, 10, 13, 15. Okay? 6 problems for you to factor. Will factoring be on tomorrow's quiz? No. Right? Okay?
Can you go over it quick?
What's that?
Can you go over it quick?
Go over which one?
No, go up real quick.
Oh, I'm sorry.
How do you get the questions?
Like that?
Oh, yeah.
You're good now? Okay. So then what I will do is I will have a quiz review. I will post that also on our Google Classroom. Okay? Shh, I don't have it ready for you just yet. I will post it to our Google Classroom by the end of block 2. I will also post an answer key again by the end of block 2. Okay? So that'll be a good way to study. So I'll put that maybe up here as well. Okay? And look at practice quiz. Okay? Use it to prepare. It will be just basically the same as the quiz with numbers changed. Okay? Yeah, of course I will.
Okay, can you call me the set today?
Okay. Yep.